Alright, so, in terms of what's vital to know, the derivative of e to the x is e to the x. There is many follow-ons from this. Sometimes you'll have a e to the function of x, and here chain rule applies. So the derivative of e to the function of x, we can think of that as the inner function, is itself, because that's the rule above, but then you need to multiply by the derivative of the inner function. And this is where we'll do plenty of practice, because if you have some function above e, the inner function or the derivative of that inner function gets multiplied out by the chain rule. And all the rules we've studied previously then apply to this as well. And this is where I want to do some of the examples. So, if we're looking at f of x equals 3, well no, I've gone too far, e to the 3x, the derivative of that is itself multiplied by the derivative of the power. In this case here, the derivative of the power is 3. And we will just write that as 3e to the 3x. And there should be a little gap halfway down your page to write that one on.
Is it meant to be a dash on the second line?
Cheers.
That's an Mentos, isn't it?
Or an error or an omission?
I think it's an Mentos.
No. Alright, next one across. The next one is, what do we have? F of x equals 2x cubed multiplied by 5e to the x squared. Alright, so now's where we start pulling stuff together. Very helpfully we've got a multiply sign in there, we're going to use product rule. So we're thinking u and we're thinking v. If u is 2x cubed, our u dash will be 6x squared. If our v is 5e to the x squared, our v dash, this is where it probably takes a bit of thinking, is the same function multiplied by the derivative of that power by the chain rule. So it's this function, and what am I going to multiply it by?
2x.
Nice. Are you guys happy if I start with a 10x? Because that 2x is coming out, so I would put a 10x here, e to the x squared. And if you want, you make a little note to yourself that that actually threw out a 2x, and that's what's gone in there to make that 10x.
Don't you take away the 2 because it's a derivative?
Yeah, so shouldn't it just be e to the power x? No, because you're doing
No,
the original function.
The function returns originally, so that e to the x squared stays the same, and it throws out the derivative of the top. So it throws out that 2x. So we don't reduce the function of e, because the e derives to itself. So if it starts with e to the x squared, it derives to itself e to the x squared, but then it throws out this multiplier by the chain rule of 2x.
So how come it's a 10x, not just a 10?
Because the derivative of x squared is 2x, and so that's that 2x multiplied by the 5 that was sitting at the front already to give us that 10x.
Oh, right.
And then we stitch it together. So f dash x is u dash v plus v dash u, and then we just throw the bits in. So 6x squared times 5e to the x squared plus 10x e to the x squared times 2x cubed. Now clearly there's some tidying, and the answers will have tidied, so they will probably write a 6 and a 5, they'll make it 30 here. Here, that 10 and that 2 will give you a 20, that x to the 1 and that x there will make an x to the 4. So it'll tidy. The other thing you will notice with this is that you're almost always going to get a common factor. So when you're differentiating with e to the x, because it appears twice in the chain rule, if you had to then go on and solve for this equal to 0, you'll almost always get this as the common factor and in this case you can pull out a 10x squared as well, but that will often reappear again and again. Alright. Next one. F of x equals 2e to the minus 3x over e to the 5x to the 7. Right. Any guesses on a start here?
We use quotient rule.
Quotient rule, yep, it's nicely set up for us. So u equals 2e to the minus 3x, v equals e to the 5x to the 7. U dash, so the function repeats and multiplies by the derivative of the top. So it's going to throw out by the chain rule of minus 3, so I'm going to write minus 6 e to the minus 3x. So it's the same function, just pulling out the derivative of that, so I times minus 3, which leads me there. And you wouldn't necessarily have to write this bit in, you can just go from there to there if you're confident to do it in your head. V dash. V dash is the same function multiplied by the derivative of the power. So what's the derivative of the power?
35x over 6.
Lovely. E to the 5x to the 7. Nice. And then, this is going to be a little messy. I'll probably start by writing the rules so I don't mess it up. F dash x equals u dash v, take v dash u over v squared. U dash v. Minus v dash u over v squared. Now, from here, I won't go on and simplify it, but avenues for simplification, you'll recognize that quite often this, and this are common factors. So if I was going to go ahead and simplify it, I would remove an e to the 5x to the 7 from everything. So it would go there, it would go here, and there's 2 here, but one of them would go, so I cross the power. So when you're differentiating with e to the x, it will often throw out repeats of itself, which you can then use to factorize or simplify. So, the first little bit of today,